Hello students, welcome to the 7th module of our review of high school pre-calculus. This video is devoted to solving 4 types of equation. We'll be looking at linear equations, quadratic, radical, and rational equations. Each one has kind of their own way of being solved, so let's look at them separately one by one. So here, basically the procedure is in the case of a linear equation. Remember, linear means x to the 1. It's basically the same as isolating a variable like we saw in a previous video. So the idea is pretty simple. We're going to keep on one side the terms that contain the variable we would like to isolate. Since we want to solve for x, we're going to keep the x's on the left and move the 7 to the other side, hence getting 2x is equal to minus 3, so that x is minus 3 over 2. That's our answer for this. Usually if you've done your work right, there's no need to check the answer. It will always work, which is not the case for all types of equations that we will encounter. So we're not going to check this answer. We're going to move on to quadratic equations. So remember, quadratic is x to the power 2. So we are looking at solving ax squared plus bx plus c is equal to 0. So we can try to factor. If that doesn't work, we can always fall back on the good old minus b plus or minus the root of b squared minus 4ac over 2a. Why don't we do this example both ways? So let's see if we can actually factor this dude. Product sum for this guy would give me, looking for two numbers, which product is negative 6 and the sum is minus 5. The numbers are quite clearly minus 6 and 1. So we will replace the middle term with those two guys. So minus 6x plus x minus 3 equal à 0. And then we shall double factor this guy. So that's 2x, x minus 3. Not much to be taken out from that guy, but I got to take out something. So x minus 3 as well, which gives us 2x plus 1. X minus 3, this product is equal to 0. So if two things multiplied by each other gives you an outcome of 0, that clearly means that either the first one is 0 or the second one is 0, or they are both 0. Solving the first one here gives me minus a half. And solving this other dude gives me x is equal to 3. These are my answers for solving this quadratic equation using factoring. Let us see if we can actually do the same, this time using the quadratic equation. So first, let's identify the a, the b, and the c, so that we can replace them properly into the formula. A, coefficient of x squared. B, coefficient of x. C, constant term when the equation is made equal to 0. So plugging it in, minus b plus or minus the square root of b squared minus 4ac, all that jazz, over 2 times a. So that gives us 5 plus or minus the square root of 25, because minus 5 squared is 25. And then minus 4 times 2 times minus 3, minus minus is a plus, so that will be plus 24, if I'm not mistaken, over 4. Going to need a little more space than I thought I would. So that's 5 plus or minus the square root of 49. What's the square root of 49? Yeah, you know that. It's 7 all over 4. So that means that I have two answers. Yes, I have one with a plus and one with a minus. So 5 plus 7 over 4 and 5 minus 7 over 4. This dude is 5 plus 7 is 12. 12 divided by 4 is 3. This guy is 5 minus 7 is minus 2. Minus 2 over 4 is minus a half. And of course, we get the same two answers as we have obtained while we were doing the factoring solution to the quadratic. Once again, since one corroborates the other one, we're not going to check this equation. Again, just like in the case of the linear equation, if you've done your work properly, checking is not needed. Which is actually not the case for the radical equation. Radical means it contains some sort of a root. In the example that we're looking at, it's a square root. So the idea is simple. We need to isolate that root and get rid of it by squaring both sides. If it were a cube root, I would be cubing both sides, etc., etc., etc. So how do I solve this? Root of 4 minus 3x. I'm isolating the root because I want to square both sides. So I'm going to move the plus 1 to the other side. 5 minus 1 is 4. And now I am going to square both sides. The square root and the square will cancel out to give me 4 minus 3x is equal to 16. And now we're down to a simple linear equation. So minus 3x is equal to 16 minus 4, that would be 12. Divide both sides by negative 3. And x should be minus 4. Now this is going to require a check because the radical equations basically need us to actually check them. So we're going to go back to the original equation, which I'm going to rewrite. 1 plus the root of 4 minus 3x equal to 5. And we're going to put in the minus 4. So 1 plus the root of 4 minus 3 times minus 4. This should be equal to 5, is it? That's 1 plus the root of 4 plus 12. Well, I think we're doing good here because 4 plus 12 is 16. 1 plus the root of 16 is 1 plus 4. Well, that's equal to 5. I guess I can stop here. It's pretty obvious that the answer checks out to be minus 4. This is now my solution set, which I will box like this so that it is clear what my answer is. One last type of equation in this quick video review of solving equations is the rational equations. So here, ratios of functions will be involved. One little good trick for those is, we've mentioned that before, A over B equals C over D means you can crisscross those guys and get AD is equal to BC. So let's take a look at this example here. I have x over x plus 3 minus 1 is equal to 6x over x minus 4. A common denominator on the left side looks like a decent idea. So that's x minus, well, this is over 1, so I guess it's times x plus 3. And the right-hand side for now is what it is, 6x over x minus 4. So that will give us what? X minus 3 is minus 3 over x plus 3. And now I'm in a good position of A over B is equal to C over D. I'm going to cross multiply and find myself with negative 3 times x minus 4 equal to 6x times x plus 3. What is this? This is minus 3x plus 12 equal to 6x squared plus 18x. Oh, x squared, a quadratic. So that means I should be bringing everything to the same side. So 6x squared, bring the minus 3 over, that'll be 21x minus 12. That is equal to 0. Now the numbers are fairly large. Perhaps I can pull out something. It so happens that 3 goes into all of these terms. So that will simplify our lives a little bit if we factor out a 3. So that's 2x squared plus 7x minus 4 is equal to 0. Good. So the factoring here is relatively easy. We can do the product sum, we can do the quadratic equation, but since the purpose was really to solve the rational equation, let's go quickly over the quadratic that we have here. If you take your time and you do it, you're going to get 2x minus 1 times x plus 4, which of course tells us that, okay, 3 cannot be equal to 0. 2x minus 1 could be equal to 0. And x plus 4 also could be equal to 0. So we have two potential solutions. One here, 2x equals 1, so x equals a half. Or x is equal to negative 4. So this needs to be checked. We need to actually check these answers, just like we did in the case of a radical equation. Let us check x is equal to 1/2. Again, it's good advice to go back to the original equation, which is x over x plus 3. So I'm going to rewrite this here. Minus 1 is equal to 6x over x minus 4. And I'm going to put in 1/2 in there. What am I going to get? 1/2 over 1/2 plus 3 minus 1. That's equal to 6 times 1/2 over 1/2 minus 4. So what is that? This is 1/2 over 7/2 minus 1, while this is 3 over minus 7/2. So that is 1/7 minus 1, and that is 6 over minus 7. Common denominator, that actually works out perfectly well. I am going to leave the checking of the other answer as an exercise. We're not going to do it here. And it actually turns out that it works pretty well, so that the solution set for the solving of this equation is 1/2 and minus 4, since both check out. So on to the last example here, some sort of a summative example that has all sorts of positive and negative and fractional exponents. 6t to the minus 1/2 minus 7t to the positive 1/2 minus 5 times t to the positive 3/2 equal to 0. Well, there's a negative exponent in there, so it's always good practice to actually get rid of the negative exponent. So 6 over t to the positive 1/2 minus 7t to the 1/2 minus 5t to the 3/2, that is equal to 0. Common denominator, since we have fractions, so the common denominator is quite obviously t to the 1/2. So I'm going to get 6 minus 7 t to the 1/2 times t to the 1/2 minus 5t to the 3 halves times t to the 1 half. All that is equal to 0. So what do we got here? 6 minus 7, 1 half plus 1 half is 1. 3 halves plus 1 half is 4 halves, is 2. And I am now going to cross multiply those guys. 0 being the same thing as 0 over 1, we all know that. So we're going to be crossing those two, and we're going to be crossing those two, and we are going to get that minus 5t squared minus 7t plus 6. That is equal to 0. So again, a quadratic equation. We kind of prefer to have the sign in front of the t squared to be positive. So let me multiply both sides by -1. So that's the same thing as 5t squared plus 7t minus 6 is equal to 0. Once again, the purpose of this is more like to play with the rational equations rather than spending a lot of time solving quadratic equations. So again, I'm going to take a bit of a shortcut here, and I'm going to factor this guy. If the factoring is not obvious to you, you can always use the quadratic equations. Either way, we are both going to end up with the same answer. So basically what I have there is that either 5t minus 3 is equal to 0, or t plus 2 is equal to 0. So either t is 3/5 or t is minus 2. Well, that is definitely going to require some sort of a check. So we are going to take a quick look at what happens. Let us start with t is equal to minus 2. So what do I got here? At the beginning of this thing, I got 6 minus 2 to the minus a half minus 7 times minus 2 to the 1 half minus 5 minus 2 to the 3 over 2. That should be equal to 0. Do you see a problem with this? I see a big problem with this. Yes, because we are taking not 1, not 2, but we are taking 3 square roots in here, and you cannot take the square root of a negative number that does not exist. So poor little t equal minus 2 fails as an answer. So that does not work. Let us check the other dude. T is equal to 3/5. So 6 times 3/5 to the minus a half minus 7 times 3/5 to the 1 half minus 5 times 3/5 2d 3 over 2. This is a check that works actually better with the calculator. So we need to actually put this in a calculator, and we're going to find out, if we do all this, that it does work. So this one works, meaning that we have actually found an answer, which is of course left to you to verify if you have the heart to putting those numbers into this equation. By the way, it's actually not that bad, because this is really 6 over 0.6 to the 1 half, which is the same thing as a square root, minus 7 times, here we go again, 0.6 to the 1 half, that's another square root, minus 5 times 0.6 to the 3 over 2, so that's the square root of 0.6 to the power of 3. And we would like that to be equal to 0. So once you use the calculator, you see that it works, so that the solution for this equation is x is equal to 3/5, and that's my only solution. And that completes